In this video, let's try to learn about ridge and lasso regression. Ridge and lasso regression. Now, ridge is also called as L2 regularization. Okay, ridge is also called as L2 regularization. Now, it is a regularization method to reduce overfitting. We already know that overfitting problem, right? We already know that overfitting problem. What it is having? Overfitting. We have lower bias and higher variance. Now, let us just draw the graph. Now, let us just draw the graph. This, sorry, this is my y-axis and this is my x-axis, right? X and y. Now I have 2 points here. Let me have some 2 points here. Now this is passing, my line is passing through these points. Now you can see here that there is no difference between my data points and the actual values. So what will be my cost function here? My cost function will be j theta 1, which is equal to 0. Now I can also write my cost function 1 by 2m summation of I is equal to 1 to m h theta of xi minus yi whole square. So this is my cost function, right? Now what I am trying to do here is, see, we have already seen that. Suppose we have some data points here. Let us just say which are very far from the regression line, and let us say these green dots are our test data. Now, when you wanted to draw the distances between draw the distances between the green point and the red line, which is actual points will be the green and predicted points are on the red line. Okay, now green points are actually the tested data. That means which is having high variance. These green points are having high variance and these red points are having lower bias. So whatever that we are talking about, whenever we are talking about training data, we are talking about bias, and whenever we are talking about the tested data, we are talking about a variance. Now we have something like this, we have something like this, and we also have something like this. So these distances are quite far. Now this problem is definitely having a overfitting problem. Now in order to avoid overfitting problem, what we are trying to do here is we are trying to add something called lambda into slope whole square. What it is trying to do here is it will have this will give another line. Let me just take new color. Let me just say this color. So here this time what I'm trying to do here is I'm trying to draw some other line which is like this. Now if I wanted to plot the distances between the tested points and the regression line, which is in the which is in green color, then my distance will be obviously quite less when compared to when compared to the when compared to the red line, right? My distances will be definitely lesser than that. So definitely my performance will be increased by looking at this line. Now what I am trying to do here is I have added here lambda into slope whole square so that this will give this will create some amount of bias in this new line, right? This will create some amount of new line, some amount of bias in this new line, and it will create some amount of variance will reduce so that our performance will increase. Now, the main idea of ridge regression is to fit this new line that doesn't fit the training data, right? Like in other words, we said that we introduced a certain amount of bias into this new line. Now, what we do in practice is we'll introduce a bias that we called as lambda, right? And the penalty function is given as this lambda into slope whole square. Now, L2 penalty is quadratic, right? Because this is a penalty function and it is quadratic in nature, and because it is having a slope whole square. Now, when lambda is equal to 0, suppose what is actually here lambda? Lambda is a cross validation which it will achieve low variance, right? Now, when lambda is equal to 0 and the whole penalty will be 0. So, we are just minimizing the sum of squared residuals. Well, we need to arrive slope close to 0. But what is happening here? Let me just say that we already know that h theta of x is equal to h theta of x is equal to theta naught plus theta 1 into x, right? Now what is our slope here? Our slope is h theta of x is equal to theta 1 into x, because it is passing through 0. Our intercept is 0 in this case for a red regression line. Okay, now we have a slope theta 1 here. Now let us say we have slope theta 1 is equal to 2. Now what we are going to get, we already know that for a red regression line we already know that we have 0 because there is no difference between the predicted values and the actual values. Now here let us say my lambda value is equal to 1 into my slope value is 2 to the power of 2, which will give a value called 4. Now here I just got a value called 4 here. Now in my next case what it is trying to happen is, you already know that in our earlier videos we have seen that the main job of our cost function is to minimize theta naught and theta 1, right? Theta naught and theta 1. Now it will do the same kind of operation here in this case. Now we have got the value called 4. Now here what it will try to do here is, now it will try to reduce this value, try to reduce the slope of 2. Let us say this time, now when we have applied this cost function, and let us say this time we have got some 1.5 whole square. Okay, now the slope has little bit decreased, right? Now the slope has little bit decreased to 1.5. Now this time what it will do, now when slope is decreased, now this function, this cost function which is here will also have some smaller value, right? Some smaller value plus 1.5 whole square, 1 into 1.5 whole square, which will give some small value plus 2.25, which will be less than 4. This will be far less than 4, which can be not far, it will be less than 4. Let us say we have got a value arrived as 3, right? Now what it will do further, it will it will go, again the main idea of cost function is to reduce this value, right? Now further again it will go and it will reduce this value, and it may reach again 2, but it will produce some result which will be nearer to the 0, but it will never approach to 0. So that is the beauty of ridge regression. So this is about ridge regression. Like now here what we are trying to do here is this, whatever the penalty is there, penalty means whatever the equation of lambda into slope whole square is there, we are trying to arrive slope close to 0. So the larger the lambda is, our prediction becomes lesser sensitive to the independent variable. So here lambda will be depending upon some cross validation here. which will bring some low variance. So this is about ridge regression. Let me tell you again, ridge regression is came into the picture because there will be some problem in the data which is called overfitting. To avoid this overfitting, we are using this ridge regression, and it will work pretty well for overfitting problems. So this is the main reason to use ridge regression. Alright, that's it in this video. In the next video, I'll talk about lasso regression.